So let's review all three conditions that must be satisfied in order for a radical to be completely simplified. And as always, if you know what the rules are, I encourage you to stop the video, write down what the rules are, and then come back to make sure that you've got them all. I'm also going to give you examples for each condition as well. So the first condition, and it doesn't matter what order they go in, but I'm just going to go in the order in which I taught them to you. The first condition is that the radicand can contain no factors of perfect squares. So I'm just going to shorten it and say no factors of perfect squares My pen is not working beautifully. No factors of perfect squares can exist inside the radical. Can exist inside the radical. So that says no factors of perfect squares can exist inside the radical. For example, if I have the square root of 54, well, that's not in simplest form because what perfect square goes into 54? 9. So we would break that into the square root of 9 times 6. And since 9 is your perfect square, you have to take out the square root of 9, and you would end up with 3 square root of 6. So that's a good example. Condition number 2, the radicand cannot be a fraction. So I'm just going to say no fraction inside the radical. Doesn't like my handwriting today, my pen doesn't. So that says no fraction inside the radical. So for example, suppose I have like the square root of 6/8. Well, the first thing that I would want to do is I would want to reduce 6/8 to the square root of 3/4. And so it's still a fraction, so then you just split it up into the square root of 3 over the square root of 4. And then you would look at your radicals and say, okay, can I simplify the square root of 3? No. Can I simplify the square root of 4? Yes, the square root of 4 is 2. So this would end up becoming the square root of 3 over 2. And then condition number 3, there can be no radical in the denominator. No radical in the denominator. Oh my goodness, that says no radical in the denominator. So for a good example would be the square root of 3/5. So yes, that is a fraction. So I need to split that into the square root of 3 over the square root of 5. And then in order to get rid of the radical in the denominator, I have to multiply the top and the bottom by the square root of 5. Because what I'm doing here is I'm multiplying by a version of 1. And the reason I'm choosing the square root of 5 is because when I multiply the square root of 5 times the square root of 5 together, that gives me plain old 5, because it would give me the square root of 25, which is just 5. And then the top, because they're both radicals, 3 times 5 is 15. So I would get the square root of 15 over 5. So to satisfy condition number 1, it's a good idea to have our perfect squares on our paper. So stop the video and just fill those in. So let's use our perfect squares to help us when we need to satisfy condition number 1. Again, if you would like to try these first 3 problems on your own, I encourage you to stop the video and try them on your own and then tune back in. You could even fast forward a little bit to see if you've gotten them correct. But if you're completely confused as to how to start number 1, then tune in right now. So what I would do first with that fraction is reduce it. You can divide the top and the bottom by 10. So I'm going to make this the square root of 3 over 2. Now that's still a fraction. So now I'm going to split it into two separate radicals. It's going to be the square root of 3 over the square root of 2. And now that doesn't satisfy the condition that says I can't have a radical in the denominator. So what I'm going to do now is multiply the top and the bottom by the square root of 2, because the denominator has a radical 2 in the bottom. Multiply the square root of 3 times the square root of 2 to give me the square root of 6 over 2. Done. Okay, this next one, number 2, it's multiplication, and the stuff on the outside we could go ahead and multiply together. The stuff on the inside, however, I wouldn't multiply that quite together yet. I would go ahead and use what I learned when I have a pair of numbers, right? So I'm going to go ahead and multiply the 3x and the negative 5x together, and that's going to give me negative 15x squared. But now, before I go ahead and I multiply my radicals together, well, let's think through this for just a second. Can't I break up the square root of 18 and the square root of 24 into things so that I can have a pair? So I'm going to think through 18 and 24. What are my factors of 18? What are my factors of 24? Well, they both have 3 in common, so I could, and 6 actually, so I could break up the square root of 18 into the square root of 6 times the square root of 3. I could break up the square root of 24 into the square root of 6 times the square root of 4, right? And so now let's put x to the third and x together, and that's going to give me the square root of x to the fourth. So now there's a lot going on here. So one thing I'm noticing is that these two square roots of 6's, well, they can go together to give you a plain old 6. So outside here, I already have a negative 15x squared. I'm going to multiply negative 15 times 6. I have that x squared out here. I'm also going to notice that I have two perfect squares. These two right here are perfect squares. The square root of 4 is 2, so I'm going to multiply the 2. I'm going to multiply the square root of x squared to be x to the second. And so far, all the stuff on the outside, I'm going to have negative 15 times 6 times 2. I'm going to go ahead and do negative 15 times 2 is 30, negative 30, and then negative 30 times 6 is going to give me negative 180. So on the outside, I'm going to have negative 180 x to the fourth, because I can put those two x squareds together. And then inside my radical, I'm going to have what's left over right here is this square root of 3. So I'm going to have square root of 3 there. So that's one way to do that. And that's a pretty hard problem. But what I'm looking for are factors that 18 and 24 have in common, and then I'm also looking for any perfect squares that I might have left over. So there's my answer for that one. All right, let's take a look at number 3. Number 3 is a fraction. So whenever you see a fraction, you should reduce, 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 reduce. So before I do anything, let's look. I can reduce what's on the outside. I can divide 3x by 6x, and I can reduce what's inside the radical here. So when I go to do that, I'm going to draw my fraction bar. When I do 3x divided by 6x, well, 3/6 reduces to 1/2, and these x's will cancel out completely. So I could put a 1 here, and I could put a 2 here. You don't necessarily need the 1 on the top currently. So now let's look at my radicals, right? Well, 5 goes into 10 2 times, and so I'm going to have the square root of 2 on the top. And then on the bottom, I'm going to have the square root of 1, but you've got an x to the third down there. You've also got an x to the third, or an x right at the top here. So this x and this x to the third, well, this x will cancel out one of the x's down there, and that's going to give you x to the second. I could write 1x to the second, but I don't need it anymore. Then I'm going to look at my radicals, and I'm going to say, well, do I have any perfect squares inside my radical? And you know what? I do. So this right here, the square root of x squared, is x. So what I have on the bottom now is 2x, and then on the top, well, 1 times the square root of 2 is just the square root of 2. So notice how easy that problem became if you can just fully simplify your fraction and then pull out any perfect squares out of your radical to start with. Then I didn't even have a radical in the denominator anymore at all. So at this point, I would definitely try to stop the video and watch and try number 4 completely on your own to see how you do. Hint, start by reducing the fraction and then tune back in. So when I reduce my fraction here, I have here 72 over 24. Reduce that fraction. 72 over 24, well, that reduces to 9/3. I divided the top and the bottom by 8. So I'm going to have here the square root of 9 over 3. And then x to the 5th over x to the 8th. Well, 5 minus 8 is going to give me -3, or you can just say, well, that's x to the 3rd on the bottom. And then the y to the 6th over y to the 2nd, well, 2 y's on the bottom cancel out 2 y's at the top, so I've got y to the 4th. Now this is still a fraction, so yes, indeed, if you haven't already split it up into the square root of 9y to the 2nd, split that up over the square root of 3x to the 3rd. So then the next thing that you should do is, well, do I have any perfect squares that I can pull out? And if you look, this is a perfect square, right? Both of it. So the square root of 9 is 3. The square root of y squared is just y. And then on the bottom, I have the square root of 3x to the 3rd. Now, if I wanted to, I could go ahead and simplify my 3x to the 3rd as well. I could split up x to the 3rd and x to the 2nd times x. Now, if you didn't do that at this step, that's okay as long as you take care of it at the end. So that's what I'm going to do here. If you didn't do that and you decided to get rid of the radical, then you would be multiplying the top and the bottom by the square root of 3x to the 3rd. But you don't have to. I'm going to pull that out. So then now what I have is 3y over x on the outside, square root of 3x. Now I'm going to get rid of my radical in the denominator. So it's always, I personally think it's always easiest to fully simplify everything before you get rid of that radical in the denominator. So to get rid of the radical in the denominator, I'm going to multiply the top and the bottom by the square root of 3x. And when I do that, the whole top, I'm going to go up here, the whole top, I'm going to have 3y on the outside, the square root of 3x on the inside of the radical over, well, when I put this all together, this is just regular 3x, but it's being multiplied by another x, so that's going to give me 3x squared. And now I'm not finished because now I have these 3's on the outside. These guys right here can cancel out. And so once these guys cancel out, what I'm left with is y square root of 3x over x squared. There you go. All right, so this next one, this is really just a fraction, time of fraction, and the same fraction rules apply when multiplying fractions. You are allowed to cross-cancel if you want, so I could cross-cancel this 4 and this 12. I could cross-cancel the 20 and the 15 because they're both radicals. However, I found that lots of times that looks confusing, so what I'm going to do is I'm just going to put them to make it one big fraction to start with. So the 12, I'm going to put on the outside, so I'm going to write 12 square root of 20 over 4 square root of 15. If you wanted to try cross-canceling, you certainly could. So I'm going to make this 12 square root of 20 over 4 square root of 15. And now I'm going to just go ahead and reduce it now. And so now 12 over 4 is 3, so that's 3 over 1. I'm just going to write 3. And then the square root of 20 over the square root of 15, well, you can divide the top and the bottom by 5. So I get the square root of 4 over the square root of 3. then I'm always going to look at and see, do I have any radicals that I can fully simplify? And the answer is yes. The square root of 4 is 2. So on the top, I have 3 times 2, which is 6, over the square root of 3. And so now I'm going to multiply the top and the bottom by the square root of 3 to get rid of the radical. Now, if you did this earlier, that's probably fine, but then you're going to have a radical on the top to simplify further. So now when I do that, I'm going to get 6 square root of 3 over, this together is just regular 3, and now I'm noticing that 6 over 3 will give me 2. So in the end, I'm going to get 2 square root of 3. And it's possible that you got the right answer doing it slightly different. All right, now to start this next problem, again, you can just multiply 3y times 8 and then put the square root of 40y next to it. You can multiply 16 times 6 on the bottom with the square root of 50y next to it as well. Also, because it's a fraction times a fraction, you are also allowed to cross cancel. Now, I know if you multiply 3y times 8, I'm going to get 24, and 16 times 6 is going to give me 96. I personally don't want to reduce 24 over 96, so I'm going to go ahead and I'm just going to cross cancel only my 8 and my 16 to start with. So you can do more cross canceling than this, but I just think it's going to be easier if I just make that a 1 and make this a 2. And yes, you can still cross cancel with the 3 and the 6, but I'm just going to put everything together now. And again, you can still keep trying to cross cancel if you want. But I'm just going to multiply. So I'm going to get 3y square root of 40 on the top. And on the bottom, I'm going to get 12 square root of 50y. I forgot my y there on the top. So now I'm going to reduce. Now that I can see it all together, to me it's just a little bit easier. So 3/12 reduces to 1/4. So I'm going to put a 4 on the bottom. I've got a y out here. You can write 1y there if you want. And then now the square root of 40y over the square root of 50y. Well, 40 and 50 are both divisible by 10, so divide that. So you're going to get the square root of 4 over the square root of 5. The y's completely cancel out. So you always want to reduce first. Then the next thing I'm going to do is say, well, are there any radicals that I can fully simplify? Yeah, the square root of 4 is 2. So the top is 2y over 4 square root of 5. Now at this point, I have two choices. I can get rid of the radical in the denominator. I can reduce 2/4 to 1/2 if I want. I'm going to go ahead and get rid of my radical in the denominator to start with. So I'm going to have the square root of 5 over the square root of 5. I'm going to multiply. And when I do that, put my problem up here, I'm going to get 2y square root of 5 over, well, this now becomes 5 times 4, which is 20. And now I'm going to reduce my 2 over my 20 here to 1/10. And I don't need the 1. I can write 1y square root of 5 or just y square root of 5 over 10. And that's my final answer. All right, so this next problem, I could just start reducing like crazy all over the place if I want to. But I sometimes think once you start crossing stuff off, then it gets really messy. So I am going to just put the whole top together and make it one big problem. So I'm going to do 2y times 5 together to give me 10y. And I'm going to put my radicals together. 8 times 40 is 320. Put the y's together. Y to the third times y is y to the fourth. And so I do know that I'm going to have to simplify that, but because I am now dividing this whole thing by 30, square root of 10y, I am going to reduce first. So let's start with this 10 over 30. Well, that reduces to 1/3, and there's a y there. So I'm going to make that y over 3. And then the 320 divided by 10, well, that's going to give me 32 over 1. So I'm just going to make that the square root of 32. And then the y at the bottom here, Well, that's going to cancel out one of the y's at the top, and I'm going to get y to the third. So the radical in the denominator is just radical 1, and the square root of 1 is just 1, so I don't really need that. But now I'm not finished with the square root of 32 over, or 32y to the third, because there's a perfect square there. So I'm going to take my radical, I'm going to make that y square root of, well, 32. Well, what perfect square goes into 32? 4 does twice, so that's going to be 16 times 2. And then I'm going to break up y to the third into y squared times y over 3. And now I'm going to pull out my perfect squares. So the square root of 16, the square root of y squared, all of those are perfect squares can come out. So the square root of 16 is 4. The square root of y squared is y, but there's another y out here, so I'm going to make it 4y squared out here. The square root of 2y on the inside, the whole thing over 3. And I'm finished with that problem.